Okay, so finishing up number 5, 5C was 24,193.77 newtons. D then asked for the centripetal acceleration. And so we know for centripetal acceleration, AC is equal to V squared over R. So 26,905.17 meters per second squared over 6.1 times 10 to the 7th meters. And you should get an AC of 11.67. No, 867 meters per second squared. That's your AC. The other thing you could have done was realizing that this was FC, you could have just divided this by the mass, and that would have worked too. And then finally, the last question asks for the mass of Saturn. So now to find the mass of Saturn, we have a whole bunch of choices. Now that we found everything else, we could use this one because we now know the period. We could use this one because we now know the speed. We could use this one because we now know the AC, which is the FG. We could use this one because we know the weight. So you have a whole ton of choices of which one to use. I maybe would do just either Newton's version of Kepler's third law or maybe the V squared one because it's pretty quick and easy. So this is E. So I might do V squared is equal to G mass of the central body over R. And so rearranging then the mass of Saturn, I think it was, is equal to V squared R over G. So the speed from the question we just finished was 26,905.17 squared. The R was 6.1 times 10 to the 7th meters. And of course G is 6.673 to the negative 11 Newton meters squared per kilogram squared. Type this into your calculator and you should get the mass of Saturn to be 6.6 Saturn 6.617 times 10 to the 26 kilograms. Okay, but you could have used any of the other equations to find the mass of Saturn too. You could have used r cubed over t squared equals gm over 4 pi squared. You could have used any of the other ones that had a mass of the central body in it. All right, so today I want you to practice some more of these.